Hello. Also, how is the Josh? So, how is your preparation? How is your vectors? How is your vectors going on? So, vectors addition completed, and I think you have interested more problems also. Okay, that's fine. Now, you know all me, myself Tawfiq Nek, and I teach here physics with some fun. Okay, now in this class we are going to start some extended of vectors. Very simple. Last we discussed addition, subtraction of vector with all its problems. Now in this we are going to study multiplication of vector. Now what is this multiplication of vectors? See, addition, subtraction, multiplication, no division. Okay, this is that. Okay, multiplication of vector means, see, when you multiply vector with an vector, you will get vector. When you multiply vector with an scalar, you will again get vector. When you divide, see, when you divide vector by scalar, you will get vector. But when you divide vector by vector, this case don't exist. So multiplication of vector we decide by two methods. Multiplication of vector, one is cross product, one is dot product. Dot product, which means one projecting on others, directly projecting, and other cross product, which is X-Men cross product. So let us see one by one what does it mean by cross product and dot product. Okay now first starting, what do you mean by dot product? Dot product of vector. It's very simple. I will take two vectors. See, I will take two vectors, vector A, let's say vector A. Okay, now one more vector I will take here, vector B. It has some angle theta. Now dot product means it's just a projection. Now just imagine if I keep here a torchlight. Okay, here a torchlight, this shadow falls here, yes or no? If I keep a torchlight here, this shadow falls here. Yes, everyone agrees? Yes, agrees, because it is falling on here. So you can say projection of B on A, this is called your dot product of vector. This is called your dot product of vector. See, we will take dot product of vector A into vector B is equals to projection of B on A. If B is projecting on A, then what it becomes? Component of B. This B projecting on A, which means component of B will be B cos theta, right? B cos theta. So first of all, A vector, A magnitude of A dot B projection, B cos theta. See, very simple. See, normally if we have nothing, here is only B, then we will take B cos theta, right? This is basically component of B, but here we are taking component of B on A, with the A. So see, it is just simple. Dot product of two vector is the magnitude and the cos of angle between them. It is called as dot product. It's just simple projecting of B on A, or else you can say component of B on A, projecting one on B. Now this is not only simple case, you can project this on this also. That time also same will happen. Angle is there now, same will happen. Projection of B on A. Okay. Now let us see some important cases on this. And see, this is very simple. It is not like vectors have derivation and all. It's very simple. Okay, now dot product. See, point to be noted, my lord. Dot product is maximum at theta is equals to 0 degree. Dot product is maximum at theta is equal to 0 degree, because if you put 0, it becomes like A dot B into A magnitude of B. A magnitude of B. Okay, now it is minimum at theta is equals to 90 degree. Theta is equal to 90 degree, it is minimum, which means A dot B becomes 0. See, if you keep 90 degree here, now it's just a multiplication of two vectors. It's just a multiplication of two vectors. When you keep here 90, cos 90 is equal to 0, then everything becomes 0. Right? Yes sir. Okay, and this follows commutative law. Commutative, very simple. See, very simple. Just now I said you can project this direction or you can project this direction, both are okay. So which means vector A cross B dot B is equals to vector B dot A. Both are okay, both are same. And even it follows distributive law also. Distributive, what it say? See, here it is like this distributive. It's equally distribute with each other. See, vector A dot vector B plus vector A dot vector C. See, distributive, simple case. It is maximum, minimum, commutative, distributive law. It follows distributive law. Okay, now can we write some more things? No, okay, if you want, take it. If there is any point, I will tell you, I will let you know. Okay, now okay, wait, I will rub this side. So now one more thing, orthogonal of vectors. See, orthogonal unit vectors. Just now in the last class I said orthogonal means it is perpendicular, which is perpendicular. Now in this, see, if let's say ij, okay, if two vectors are perpendicular to each other, then it will become 90 degree, which means it is it is j. ij dot product of ij becomes 90 degree. Yes or no? See how it comes. Ij is equals to I into j cos 90 degree, which is equals to 0, because these both are perpendicular to each other, I and j. And similarly ijk and jk is perpendicular to each other, dot product of jk and dot product of ki, these also perpendicular to each other, which is equals to 90 degree. So it is equals to 0. Okay na? Yes, fine. But here this is not equal to 0. J into j, it is not equals to 0. K into k, it is not equals to 0. And the dot product of two vectors, dot product of a same vector with itself, see, I am just telling, this is vector A, dot product of this vector with itself, it is possible. See, because with itself theta is equal to 0 degree, that time a dot product of a with respect to a is equals to a cos 0, which means is equals to a square. Okay, now I will give you one beautiful example. See, okay, let me take here. Now if I take vector 2i plus 3j plus 2k, okay, this is, let's say, vector a, and one more vector b, which is equals to let's say I plus 2j plus 3k. Okay, now how to do dot product of this both? Okay, let me tell you how we'll do dot product of this. Okay, now a dot product of b, and they are given for suppose just imagine theta is for some time, just imagine theta as t 0, because if theta is 0 I can easily tell you how it works. Okay, okay, now write it here. First 2 theta a plus 3j plus 2k cap magnitude dot of I cap plus 2j cap plus 3k cap. Okay, now come, how we'll do? We'll say first multiply this with this. 2 ones are 2, 2 ones are 2, I dot of I. Now this I into I, which is in same direction. I said I into I, which is in the same direction. Unit vector into unit vector is 1, right? Unit vector into unit vector is, the value is 1. I can skip it. 2 ones are 2, I becomes unit vector 1 plus. Now do we need to do this? I into j, 2i into 2j. Why we will do this? I is this direction, j is this direction, 90 degree. If you do 4 into I into j, this is equals to 90 degree. Okay, let's see. Let us write fully. Why simply for confusion you. Okay, multiply each and every term of this. 2i into I plus 4i into j plus 6 I dot of k, okay, plus 3 j dot of I plus 6 j dot of j plus 9 j dot of k, okay, plus 2 k dot of I plus 4 k dot of j plus 2 to the 6 k dot of k. Now see carefully, it is I into j, ij perpendicular to each other, which means this becomes 0, because perpendicular to each other angle is 90 degree, cos 90 is equal to 0. Now it is ik perpendicular 0. Now it is ji 0, it is jj, it is jk 0, it becomes 0. Now what you remain with? 2 I into I dot of I plus 6 j dot of j plus 6 k dot of k. Okay, now I is in same direction, which means 0, which means this becomes 1. See, this is unit vector like 1 dot of 1, which is 1 cos 0 is equal to 1, which means it will totally become 1 value. It value becomes 1. So you remain 2 plus 6 plus 6. Totally you will get answer 8. See, 2 ones are 2, 3 twos are 6, 2 twos are 6. I just want to tell you this, whenever you find dot vector, just multiply this first term with I only, 3 j term j only, k term k only. Okay, now this is the best example when you are taking angle is equal to 0 degree. Okay, if someone wants, they can note it. So now next is cross product. Dot product multiplication over. It's just a projection of one on another. But this is cross product. Cross product now it's little huge. It's a small topic in itself. Cross product of two vectors. How you take cross product of two vectors? And I will tell you how. See, for suppose let us take two vectors. See, one vector this direction, other vector this direction. For suppose one vector this direction, vector A, and let's say vector B. Okay, now if you are doing cross product of these two vectors, then its product will always perpendicular answer. When we are doing two vector cross product, then the answer will be perpendicular. It's just simple. When you are crossing two vectors, your resultant will come perpendicular. When you are cross multiplying two vectors, resultant will come perpendicular. Why we do dot product, why we do cross product, we will learn, don't worry. Now when we are crossing two vectors, our resultant will come perpendicular. Just just listen everything. When you cross two products, see, it's our lines will be like this now. One like this. Okay, see, this one, this one. Okay, when you cross x, y, z. Okay, now it is when you cross x cross z, you will get answer y, which is perpendicular. When you cross y into x, you will get answer which is perpendicular to this. See, when you are talking in 3D, it will be like this, perpendicular. This one is perpendicular to this one is perpendicular to this. Similarly, when you do here z into x, okay, x into y into, okay, there is one more thing now, y into x, y into z, okay, y into z, you will get x value. All are perpendicular. Okay, this for understanding. Now I will tell you, this is your cross product. Now when you do cross product of two vectors, your resultant will be perpendicular, and this side it will become now magnitude of A, magnitude of B, sine theta. And there is one more thing. Okay, let us write here neatly. Two vectors, very neat. Vector A, vector B with some angle theta. Okay, now if we do our cross producting, see, answer will be in this direction, resulting A, B, this direction, but this resultant is equal to the area of this. This resultant is equal to the area of this. Wow, what a beauty. See, what a beauty. This is how we learn cross product. When we are doing dot product, it's just a projection of one product on another product. But when we want perpendicular answer, we are using cross product. When we are projecting, dot product. When we want perpendicular answers, when we want area of triangle, area of parallelogram, diagonal area of parallelogram. See, I will tell you. See, now we discussed this one, right? Parallelogram. It was like this parallelogram. Now what if I want this area, this line area, or what if I want full parallelogram area? What if I want triangle area? At that time I can't use projection. That time we use this cross product. Okay, now understand why we use cross product, why we use dot product. Okay, areas and all fine by this one. See, just simple. We want this area. Forget about this. We just want this area. We are cross producting. Here coming some area. That area is equal to the perpendicular of resultant. Wow, super. Okay, now let us study some properties. Very simple. Properties. One, first property, maximum at theta is equals to 90 degree, because sine 0 is equal to 0. Okay, and minimum at theta is equals to 0 degree. Wow. Opposite to that. Wow, super. And this don't follow commutative. I will tell you why. It won't follow no commutative. No commutative. Which means is not equal to. Okay. Why it is not equal to? No. Why it is not equal to? It is also a beautiful thing. Why it is not equal to? Okay. See. If I take two vectors. Let's say x. Let's say y. Okay. Now, for a better understanding, if I do cross product of x into y, I will get z axis perpendicular. I will get z perpendicular. Fine. Up to here, everything fine. We are getting perpendicular. We are going this direction. We are getting perpendicular. But if I do like this, I will get answer, but in opposite direction. See, the thing is just okay. Remove this. Use your right hand rule. Now, right hand. Okay, now right hand. This your thumb, your fingers is there. Now your fingers keep hand like this. Okay, now on one vector 1, x vector projecting towards y vector. See, like this, x vector cross product with y vector, x vector cross product with y vector, x vector cross product. This is going to be product. Cross product is y vector. Thumb indicates the resultant vector. Because this is a 2 dimension, I am indicating like this. Okay, it comes like this. Okay, right hand rule. Right hand rule. Important. Note down if you want. Right hand rule. Okay. Right hand rule. How to show the resultant direction? Now, when I keep at x axis, rotate at y axis, resultant is coming this direction. Okay, fine. But when I keep at y axis, rotate at x axis, resultant is going inside opposite direction, which means for this my resultant, this is resultant simple like this, but for this becoming minus z. Minus z. See da, very simple. Now come here. Now okay. See, from projection A, I am going to see A cross product B, A going to B. Okay, A cross product B, my direction inside, thumb inside. Okay, inside, positive. But if I go from B cross product A, it becomes outside. Both are opposite. Both are not equal. Vectors are not equal. But magnitude is equal. But magnitude is equal. Okay, na? Magnitude is equal. It follows distributive law. Yes, carefully. It follows distributive, but we must do very carefully. Very carefully. Okay, now how means very simple. See, from childhood you are doing, now also we will do plus b dot of c. Okay. This is all about your cross product, and same orthogonality is there, and we will see, and how to find this area or this vector we will discuss. Don't worry. Now if you want, just fill it your books. Fill it. Okay. Okay, now come orthogonality. Let us see orthogonality unit vector. Orthogonal orthogonal unit vector in cross product. Okay, cross product. Now what is a cross product? Cross product means vector A cross of B, vector A cross B is equals to magnitude of AB on sine theta, right? It was right. We just now wrote this. If it is A, if it is B, this becomes C, which is equals to A cross of B, perpendicular, and this is equals to area again, A cross of B. Right. Now if you come for orthogonality, orthogonal vectors means what? Orthogonal vectors means perpendicular vectors. Orthogonal, see, this is only right, perpendicular to each other. This is x-axis, y-axis, z-axis. The vectors which represent this I, j, k are called orthogonal unit vector. Now if you come to write orthogonal unit vector for cross product, now it becomes very interesting. How? See, how? Let us rub this. Okay, how? See here. Now if I take I into I, okay, I into j, I into k, arey baba, very, okay, ij, j into j, j into I, j into k, and one more thing it's coming, what is k into I, k into j, k into k. Okay na? Yes sir. Okay sir. Now I into a are unit vector in same direction. If it is same direction, angle becomes 0. If angle becomes 0, then what happens? See, it is unit vector, one value, one will come. Angle becomes two vectors in same direction, same vectors, same direction, then angle becomes 0 degree. Then I into I becomes 0. We can't take. And j into j becomes again 0. K into k becomes 0. How means I will show you one vector. See, if we take I into I, which is unit vector 1 value, which is equals to 1 magnitude 1 sine of 0 degree. Sine 0 is equal to 0, everything becomes 0. Fine, right? Okay. Now come to this ij, ik, ji, jk. No, it's not 0. See, this and this is perpendicular, and resultant comes here k. I and j is perpendicular, resultant come here j and a is perpendicular, resultant come here k. Jk perpendicular, resultant come here I. Kj perpendicular, resultant come here I. This one perpendicular, then resultant come here j. Is it true? No. There is a small flow in this flow. Some become negative, some become positive. I just said when you are going from A to B, positive, B to A, negative. Similarly here, how to identify that? There is one small, I will show you one small thing idea. See, write this I, j, k. Okay na? I, j, k, and again I, j, k. If you find series one by one, next one is positive. If I into j, okay, now it is okay na. If I into j you are getting, then k is positive. If j into k you are getting, then I is positive. If I in k into I you are getting, j is positive. Okay, if you are getting j into k, then I is positive. But if you get reverse j into I, that time k becomes minus I. Okay, now I into j, next term is k, which means this become positive, which means when we are going from I to j, positive answer we are getting. Now similarly, when we are going from j to I, we are getting, okay, j to I, okay, where is j to I? J to I, we are getting negative. See I just said you, see, this is not equal to this, but this is equals to this one. Now we are cross product from I to j, answer is here. From j to I, answer is here. Now ik is there, I and k, no, I and k is very far, very far. Now here somewhere other word jk, okay, jk is there after I, positive, okay, this becomes negative, ki, this becomes positive, ki, this becomes positive, kj is reverse, then it become negative. See, to remember this, it's very hard. So just follow this ijk. If you are getting I into k, then I into j, then k is positive. If you are getting j into k, then I is positive. If you are getting k into I, then j is positive. If you are not getting anything like this, if you are getting reverse terms, then it is negative. Okay na? Okay. K into I, j. Okay, k into I, j. Super. Now can I wrap this? So this also very headache, right? Sir, how to remember all this? Headache. Okay, I will give one more trick. Now you know mathematics. You know mathematics. Yes sir, we just know one thing, mathematics, right? Mathematics. Now let us take one vector is equals to xi plus yj plus zk. B vector is equals to 1 1, okay na, x2i plus y2j plus z2k. Okay, so now cross product, if you want cross product, just do one thing, very simple, use your determinant or matrix method. See, write it here, I, j, k. This will be negative, okay na, negative, positive. Now write the values of first one, xi, y1, z1. Second one, x2, y2, z2. Solve it, you will get your answer. Same. How same? First we will keep this one, I is equals to y2 x2 minus of z1 y2 minus j is equals to x2 x1 z2 minus z1 x2 plus k is equals to x1 y2 minus y1 x2. Now sir, from this how can you calculate? What you are saying from this? Array, there I into j you said na something. Now see here, just absorb this fellow. Just absorb this fellow. Now y1 z2, y and z xyz minus zy xy. When you multiply this, it becomes positive. Positive because xy, it is series xy. Now see here, it is zy, opposite of this. When you multiply with this it is becoming negative. Here it is becoming negative. This is what I am trying to say you. Now understood? Okay. Now see, by this also you can find your area. Okay now? Okay. Any doubt in this? Any doubt? Any doubt? Any doubt? Any doubt? Okay, you can note it. You can note down. Okay. Okay, now formula to find areas. Formula to find areas. First area, let us say triangle. Triangle, all you know, triangle. This will be your triangle. How to find area of this triangle now? Triangle. This is triangle. Okay, triangle. How to find area of triangle? Very simple. Half into A cross B. whatever the sides, just A cross of B side. Okay, now triangle. Now parallelogram. How will you find area of parallelogram? Is two sides cross multiply. Just now I said for parallelogram, two sides cross multiply. And one more thing, area of diagonal of parallelogram. It's very simple. Half into A into B. Okay, now here we use our cross product. This is why we learn cross product in this chapter. Okay, first dot product just to see projection of one vector on other vector, but cross product to see area, to find area or perpendicular. Whenever you find perpendicular, use cross product, which is easy. Okay, now after this let us see sine angle and cosine angles, which is also very good thing. First of all let us see. Okay, okay man, so we discuss many kind of triangles, many kind of how to add vectors, but one small thing I said, when you have this kind of vector, resultant will come here, right? But what if you have this kind of vectors, at that time what you want to do, what you want to use? I will tell you what you want to use. First you will use cosine rule. It says cos of A is equals to vector B plus vector C minus of A is equals to 2BC. How it comes, I will tell you, don't worry. Now just say this is your one vector, this is your other vector, this is your one more vector. Let's say this is A vector, this is B vector, this is C vector. Okay now? Okay. Now it has angle 60 degree. 60 degree. Let's say theta. Let's say angle theta. Now it's extend up to here. It goes up to here. Now what is this angle? This is your 180 minus theta, right? And this is your 180 minus theta, and this is your 180 minus theta, 180 degree minus theta, right? Now it is clear. Now if you see, it's creating a circle, loop. It's creating a loop. So you can write like this: vector A plus vector B plus vector C is equals to 0. Yes, we can write this. Now can I write like this? Because it is creating a loop, so it becomes 0. Yes, I can just shift it from this side to this side. Now multiply it, square on both sides. It will become like this. Square on both sides. It's become like this. Minus. Okay, it's become like this, squaring on both sides. Okay sir, super sir, it become like this sir, we agreed sir, okay, now you will agree, just squaring on both sides. Okay, now individually I will multiply B vector dot B vector and BC plus B vector dot C vector and plus C vector dot B vector plus C vector dot C vector is equals to, here it becomes A square, right? Here it becomes A square. It's A square. Okay, let us do whatever it comes, we will see. Now this becomes your B square plus this becomes, I can write this as commutative law. It follows commutative law. I just said it follows commutative law. Plus C square is equals to A square. Now it is 2 times B square plus C square plus 2BC is equals to A square. But one more thing. Okay, it is in vector form, right? Okay, now if you want to remove this vector form, if you want to remove this vector form, it will become like this: b square plus c square plus 2bc cos theta is equals to a square. Right. Now b square plus c square minus a square is equals to 2bc cos theta. Now if I send this downside, b square plus c square minus a square divided by 2bc is equals to cos theta or cos of a. Cos theta, if you are taking for cos theta, if it's cos theta, so here it becomes square. Oof. Okay na? Okay. Now see, if you are taking angle, let us change angle for more clarity. Okay na? Let us take here beta, alpha, gamma. Okay. Okay, whatever, if you take angle, it's on you, but you get perfect answer. That's all. See, what I want to tell is, when you are doing this, your one angle, let's say alpha a. Okay, this I will take a, b, c. I will take ABC. Now I will get see, we can get that also, but this is very clear for me. Okay, now if it is angle between this and this is this one, this and this is this one, and similarly angle between this is equals to b is there now, so b becomes this side, remaining is a square plus c square divided by 2ac. Now cos c is equals to, c means it's go like this direction, a square plus b square divided by 2ab. This is why I took that side. This is your cosine angles. It will be useful when you are doing like these things. Okay. If you want, take down. Okay. Now it's time for last topic of this chapter: sine rule, or you can say Lami's theorem, Lami's law. Okay, sine rule or Lami's theorem. Okay, Lami's theorem. So this is also same thing we'll draw. B, C. Okay na? Okay bachao. What's going on? Just nothing sir, just chilling, eating, and then repeating. We don't want NEET, we don't want IIT sir. Why simply sir? We'll just join a normal school and enjoy the life. Okay. Now come to sine rule. Same again. A vector plus B vector plus C vector is equals to 0. Now I will do one small thing, variation. I will cross multiply. I will multiply this. Okay now? Yes, okay. Now simple thing. See kiddos, I know you are feeling bored. Because you are bored. This becomes 0. Yes sir, this becomes 0. This becomes like this. This becomes like this. Now can I write this as this? Yes sir, your wish. You can write just using here commutator rule. Like if you reverse the direction, negative reverses. Yes sir, you can use your wish sir, your wish. You can use whatever you want. Now similarly I will do for B also. B, if I do for B, it will be like this. This becomes 0, this becomes 0, then you will be left with B dot of A plus B dot cross of C is equals to 0. Now I cannot write like this. B cross of C is equals to minus B cross of A. Yes sir, you can write this. Now even I can write this as like this, like a wow, beautiful. Yes sir, yes sir, yes sir. Now C1, C2, compare both, so you can write both as like this. A cross B is equals to B cross C is equals to C cross A. Yes or no? Yes, you can write like this. You can write like this. Now I will use this area. I will do this area. Now see, cross product. So can I write like this? AB sine theta. BC, yeah. Okay. BC sine theta is equals to CA sine theta. We are just writing cross product full form. Cross product full form. Now divide this all by ABC. If you divide this all by ABC, you will left with sine theta divided by A is equals to sine theta divided by B plus sine theta divided by C. Now see, this is AB. Yeah, see, angle. Now this becomes your Lami's theorem. You can say it as Lami's law. Okay, now this valid formulate triangles, Lami's law. Okay, there is one more thing. If you want, you can include sine theta is there, so pi minus theta you can do yes. If you want, you can do pi minus theta also. But no need. When you are getting answer for this, then why simply do? See, here you can substitute pi minus theta. See, if you substitute there sine pi minus theta, again it will be in pi, it won't change. Sine minus theta, again theta. Okay, this is only fine. Here, see, here in this triangle, now we will substitute pi minus theta. If we want pi minus theta, if we substitute, we will get same answer. Okay, this is called your Lami's theorem, and this is we can use to find easy method. See, they will give angle value. You can easily find. Okay, now. Okay. This is see, and one more last thing is there. I just want to say one last thing. One last thing. See, when we have like this, okay, now angles. Let's say it is A vector. This is B vector. This is C vector. Here is alpha. Here is beta. Here is gamma. At this time, very simple. What you will do? Very simple. See. A, vector A, magnitude of A, opposite angle, vector A, opposite angle, sine alpha is equals to vector B, magnitude of B, opposite angle, alpha, beta, gamma, sine gamma. Not only gamma, you can take whatever you want. C is equals to opposite angle, sine beta. Okay, just reverse of this. Okay, now. Fine. And one more thing, when three forces acting at a point, and its angle is 120, then the resultant will be 0. See, I will tell you how. Don't worry, we'll discuss this last thing and we'll end it here. See, for suppose it is a point, now if it is f, just imagine f and f acting at 120 degree at 120 degree, both are f. Now both are f, it resultant comes exactly here, and it is 120 degree, resultant will be same, 120 degree resultant same, and this is f, this is the opposite direction, so cancel each other. So you can say three vectors are in 120 degree with each other with same magnitude, then the resultant is 0, okay. So guys, theory, that's it, concepts, that's it, problems still there. Yes, so we have left with problems. We'll discuss dot product, cross product problems, many problems, as much as we can. I got leg pain, sorry. Okay, so in next class we'll discuss problems and we'll end this whole chapter. Okay, I think you like this chapter. If you like, thank you, good. If you are seeing up to now, then congratulations, you are going to IIT. Bye, I will meet you in next class. Until that, bye.